Welcome to the webinar, tag Advanced Time Series ARDL and NARDL models. Today, being the first day, what we'll be looking at in this class, I'll be putting you through how to conduct augmented ARDL model, known as augmented autoregressive distributed lag model. So here, let's show the theoretical exposition. Let's deal with theoretical exposition. So let's assume that we want to examine the impact of exchange rate fluctuation on economic growth. Here we have the dependent variable. Real GDP is in log form. That is our dependent variable. And we have the target variable. That is exchange rate is also in log form, nominal exchange rate. And we have control variable. We have two control variables, that is inflation rate and trade openness will be used as control variables. So this is a general specification for ARDL model. So we are moving from ARDL model, the traditional ARDL model, to augmented ARDL model. And we are going to see what makes it to be augmented. So this model specification for augmented ARDL model is the same as the specification for traditional ARDL model. So let's have our general specification. We have ARDL PQ1, Q2, Q3. This P1, Q1, Q2, Q3, they has the lag of our variables. So we have this specification here. You can see we have the lag, okay, the lag of the dependent variables, and we have the lag of dependent variable. Then we have our target variable exchange rate. You can see this one starts from level, not from lag. So where this I run from 0 until the optimal lag that is chosen, okay, either by AIC or BIC or other criteria that is used or that are in choosing optimal lag. Okay, so we also have our target, our control variable one inflation rate. You can see it also starts from 0 and end at Q2. Then we have the last control variable, which is the second control variable. So this is the specification. You can see the same specification as the traditional ARDL model. So here are the definitions of the parameters we have as defined before. You can see we have the log of real GDP, we have log of exchange rate, inflation, trade openness. So you can see that inflation and trade openness are not log. Why? Because they are in percentage. So variables in percentage should not be log. Okay. So we have the intercept, then we have other things. Okay. So we have the bond test equation. Bond test equation. This is the specification for bond test equation. It's also known as unrestricted error correction model. So here is where we have augmented. Okay, the usual bond test has two tests. That is the F test on the F test on the coefficient of the lag dependent variable and the other expansive variables. So like we have here pi1 equal pi2 equal pi3 equal pi4 equal to 0. That is the null hypothesis, okay? And the same as we have under Pesaran, that is the traditional ALDL model. And where the alternative says that one of the pi is not equal to 0, okay? So rejection of this hypothesis is what we are after. So also the other test, as we have under traditional ARDL bond test, is the t-test on the lag dependent variable. Okay, the t-test on this pi1, only this pi1 here. Okay, so we are going to carry out f-test on these 4 coefficients. that is pi 1, pi 2, pi 3, and pi 4, whether they are simultaneously equals to 0, okay? And the second test, like I said, on a traditional ARDL model, is the t-test on this pi 1, that is the coefficient of the lag dependent of the coefficient of the lag dependent variable. You can see. So why we call this augmented ARDL model is because of this additional F test that is on lag independent variables. Okay, the additional test on the coefficient of the lag independent variables. So traditional ARDL model, traditional ARDL bond test only captures tests A and test B. That is the F test. We have the overall bond F test and T test on the lag dependent variable. And it does not include this additional test. It is this additional test that makes this these techniques to be called augmented ARDL model. Okay, what is augmented is the test. Okay, not actually the model. Okay, so we now say uh, for this additional test on the lag independent variables, like I said, we have pi 2, pi 3. You can see after testing all these coefficients times the 4 coefficients we have here. So the additional test exclude the coefficient of the lag dependent variable, which is pi 1, and a test for the test whether the coefficient of the lag independent variables are equal to 0. So as a note, long-run relationship exists if and only if H naught is rejected for the three tests. So for us to conclude there is a long-run relationship, okay, for this test we must reject the null hypothesis for all these tests. Okay, and here is the error correction model for this same estimation technique, okay, from this day model. So you can see this is the error correction model, okay. So we have this to study that, okay, and we have the ECT, the first lag of ECT we have here. Okay, it's very important that the lag error term derived from the long run equation. Then we have psi. This coefficient is called psi. You have this psi, it represents the speed of adjustment coefficient, and it's expected to be negative and statistically significant. Okay. Apart from that, we expect the absolute value of this psi, okay, to be less than 1. So if the absolute value of this psi, that the speed of adjustment is greater than 1, so this can result from misspecification error. So we need to check our lag. Maybe we should increase the number of lag we've included in our model before, or we reduce the number of lag and see whether there will be changes. Okay, so say a statistically significant negative value of this psi confirms that deviation from the long run equation are correct over time. So it's a confirmation that there's a long run relationship. If this speed of arrangement is negative and the absolute value is less than 1 and also significant. So it's a confirmation of our bond test. Okay, the confirmation of our bond test. So we say note, not note and note, this psi coefficient of this ECT, okay, we have here, this coefficient here, that we have here, this psi here, okay, the psi we have here is equivalent to pi 1, is equivalent to this pi 1. Okay, that's what we are saying. It's equivalent to pi 1. Here we have a pi 1 here is equals to the psi. It's always equals to the psi. Okay, anyway. Okay, and the corresponding long run, the corresponding long run model, the corresponding long run model is the corresponding long run, that is the corresponding AARDL, not FAARDL. Is the corresponding AARDL long run model is given as this. You can say this is the long run model. Okay, so we have where this intercept here means the the alpha naught divided by pi. So this alpha naught we have here divided by pi. Okay, so to get the long run coefficient, so we are going to divide each of these coefficients by pi 1. So to get the long run intercept, it's going to be this alpha naught divided by pi 1. For this one, it's going to be pi divided by pi 1. For this, it's going to be pi 3 divided by pi 1. Then for this, it's going to be pi 4 divided by pi 1. Okay, you can see that is all what we did here to get the corresponding coefficient for the long run model. Okay, so that is about augmented ARDL model. Now let's move into STATA. We move into STATA. So we are going to, wherever you are in STATA, I said the first thing you are supposed to do or you are recommended to do is to ensure you set your working directory to that folder where you have your do file and your data set. You must put your do file, the do file you want to use for the analysis and data set you want to use. You must create a folder, maybe on your desktop or somewhere else where you put all the do file and the data set you want to use for the analysis. So I want to locate that. How do I do that? I go to file. Okay, let me take that again. So I go to file, then I click on change working directory. So I will locate the file. Okay, I will locate, now I will locate the folder. Here, I have the folder. So the folder is named ARDL model with STATA. So I just set my working directory. So I've set my working directory. Okay, now the next thing is to open the do file I want to use for the analysis. So let me open the do file. I go to file, then click on open. Click on open. The do file I want to use is AARDL do file. So I click on that. So I wait for it to open. So here is the do file I want to use. Okay. Now the next thing is to import my data set. I want to import my data set. I can actually do that manually. Okay. Let me do that manually. So I go to file, then I go to import, then Excel sheet because my data set is in Excel format. Then I click on browse. Then here you can see STATA took me to that folder because I've already set the working directory. I've set that folder as my working directory. So then I click open and see, is that what I have? Yes. So I click on import first row at variable names. Then I click OK. So with this, my variables, with this, my data set has been imported. So I can just type BR, that's browse, in this command to check my data set. You can see this data set has been imported. Okay. Now let me go back to STATA environment. Okay. You can see, then let me go to my do file. Here is my do file. Okay. Now the first thing to do is to make sure I set my data sets as time series. To declare data set as my time series, I'm going to run the command tss et. Then I put the time variable, which is year. Year is the time variable here. In my data set, I have year as my time. If it is month, I put month, but this is year. The name I use as my variable name, that's what I'm going to use. Year. Okay. So I put year there. So I'm going to put year in that command. So I will run that. Let me run this. Yes. I just set as my working directory. I just declare data set as time series. You can see time variable year, then 1981 to 2003. Then the unit, that is, we have one interval between 2 years. That's 1981, 1982, 1983, just one interval. That's what it means. Then the next thing is to generate the log series. Okay, mind you, we here said we are going to use the log of real GDP, log of exchange rate, but we are not going to log inflation and trade openness. So that is what we are going to do. Now we are going to log both real GDP and log and exchange rate. So here the command we are going to use, we use gen, that's generate. You can write it in full. Generate hell real GDP. That's the name I want to give to my name variable I want to generate. Then I say it's log of real GDP. Then also generate LEXR as the log of exchange rate. Okay. What I have in the brackets must correspond with the variable names I have here. Real GDP EXR. Okay. Now moving back to the do file. Now let me generate log series by running this code. Okay, 28 and 29. So let me highlight and execute here. Let me check the STATA environment, whether it has been, you can see it does not return any error, so it has been generated. Then I go back to my do file. So descriptive statistics, in a standard analysis, so as part of the preliminary analysis, you are expected to carry out your descriptive statistics and also unit root test. Okay, in our previous webinar, okay, in our last webinar, so where I put you through how to conduct unit root test on time series. Okay, so you already know that. So but as a standard analysis, you are meant to conduct unit root test. Okay, but in this class, we are not going to consider that anyway. So our focus will be on augmented ARDL model. Now, the command we are going to use is AARDL. AARDL. That's the okay. So you can read on this command by coming to the STATA environment. In command, just type AARDL. So you must have installed this AARDL before you can type ARDL in order to read about it. So it will bring information about this and the model you can use to run. You can see all these models. You can use to run all these models. You can see all these 8 models. You can use this ARDL to run them, like augmented ARDL, bootstrap ARDL, AARDL, we have Fourier augmented ARDL, Fourier bootstrap ARDL, and others you use to run. You can read about this command at your own pleasure time. So now, going back to the do file, okay, so you can see the structure. So we write the command, then the dependent variable first, followed by we have our explanatory variables. Then comma type the kind of model you want to run, because this command can also be used to run Fourier ARDL and ARDL and other families of ARDL model. So we are going to integrate the type here that we want to run augmented ARDL model. Okay, then we set the maximum length, okay, the standard, okay, 4. So except if we experience misspecification error, so we always put maintain this default, okay, which is lag 4. But if we experience model specification, maybe at the end of the day, the result indicate that there is serial correlation, we may reduce this lag and see if there are changes. If there are no changes, we can also increase the lag until we're able to achieve no serial correlation. Then information criteria. Also, this is the default, but I just put it there, okay, so that you know that you can also specify these information criteria. So we have case 3. That is the popular case, okay. That is the popular case where we have unrestricted intercept and no trend, okay. You know that 5 specification, okay, of ARDL model as proposed by Pessaran and Smith, okay, as proposed by Pessaran, okay. So we have this. So the popular case, we are going to use the case of unrestricted intercept and no trend, okay. So now let me run this. If we run this model, we run this line of code, okay, we are going to see what happens. Let's wait and see. Before we can interpret this, we need to first check our Before you can interpret this table, you need to first check our uh, uh, bond test. Okay, bond test. Okay, like I said, the traditional ARDL model is based on these first two tests. That is the F test for overall and also overall independent coefficients, independent variable coefficient, and T test for the coefficient on the T test on the coefficient of the lag dependent variable on the independent variables. Okay, is what makes this model to be augmented. Okay, this traditional ARDL model is augmented by this third test. Okay, so we expect to reject the null hypothesis, like I said, when we are dealing with the theory here, that we expect to reject all this. Okay, so in order not to waste our time, we can just look at this p-value. Okay, this p-value, you can see this indicates significance at 1%, mean that we reject the null hypothesis. For this F test, for this T test, we also reject the null hypothesis, and for this last test, we reject the null hypothesis. Okay, you can see the conclusion is that there is co-integration. Okay, after the establishment of configuration, we can now interpret our error correction model. Here is our error correction model. Okay, we have this error correction model. Here we have this adjustment. We have the adjustment here. Okay, so after establishing the co-integration, that is long-run relationship, we can now interpret our result. Okay, let's start from this adjustment. So we have the log 1 of log of GDP. This represents our ECT, the first log of ECT. It is negative as expected and also significant, and it's less than 1 in absolute value. So it means the interpretation of this one is that 18% of the definition is corrected. Okay, the speed of arrangement is 18%. Okay, so we must have confirmed that it satisfies the requirement before you interpret it. And we also have the long run coefficient. That is, in the long run, you can see this, I know this p-value, the coefficient of this log of exchange is not significant. This implies that exchange rate does not have significant impact on GDP in the long run. You can see this is negative, this one is negative. So it means that this one is significant and the coefficient is significant. It means that inflation has negative impact on real GDP in the long run, and also to trade openness. Okay, you can see it has inflation has significant negative impact. Okay, on economic growth in the long run. That's on real GDP in the long run. While trade openness has positive and significant impact on real GDP in the long run. Okay, that's what it means. Okay, now you can see that you can also interpret the coefficient. How do you interpret the coefficient? This one is not in log form, while log of real GDP is in log form. So we are going to multiply this coefficient by 100 to interpret that. So when you multiply this by 100, so you are going to have 1.5. Okay, so it means that if there is 1 percentage point increase in inflation, so real GDP will decrease by about 1.5%. Okay, 1.5%. That's what it means. And for trade openness, if there is a 1 percentage point increase in trade openness, there will be about 1.7% increase in real GDP. So that's what it means. So also moving to the short run, you can see the short run. Move to the short run. In the short run, you can see in the short run, this is the lag. So we check this one if they're persistent. This is not significant. So none of this is significant. So meaning that a log of GDP, meaning that real GDP is not persistent. Okay. Anyway, so the focus is on log of exchange rate. You can see based on this this lag difference one, you can see that it means that in the short run, exchange rate has negative impact on real GDP. Okay, okay. Now I'll go check this one. also check this one. We can also see here that initially, okay, inflation has negative impact on real GDP, but later becomes positive. The impact becomes negative, positive, okay, and with time it becomes yes, with time it becomes positive. And see, this is never positive, positive, positive. Okay, initially it becomes uh negative. The impact of inflation on real GDP is negative. Okay, okay, before, but later it turns positive. So you can also check that of trade openness. For trade openness, the input, check the significant ones. Okay, you don't need to interpret the one that's not significant. So you only can split this one and this one. The impact of trade openness on real GDP in the short run is also negative. It's also negative. Okay, we are done with this. So coming to diagnosis test. Diagnosis test, you can see there is no the errors are normally distributed, no serial correlation, there's almost correct, and the model is where is correctly specified, so we are happy. This also makes sense to us. This also makes sense to us. Okay, those are the important things you are expected to interpret. This one talk about the impact multiplier. Impact. Lastly, we have this half-life. Okay, this half-life tells us about the number of period it takes the half of the shock. Okay, the half of shock to vanish. Okay, we have persistence. This is the half. Okay, this correspond. This line represents the half. Okay, the half where the half of the shock. Okay, vanishes. Okay, you can see corresponding to 3.5. Okay, you can also check the movement or the impact of trade openness on the GDP. Okay, also the impact of inflation on GDP. Okay, is falling. Okay, while trade openness is rising. Okay, and also exchange rate is rising. You can see in the long run. Okay,